chemistry, chemical kinetics, and solutions. All these 3 chapters you have studied in the +2, and therefore I am not going to any introduction. Directly I am going to the questions. Surface chemistry അതോടൊപ്പം തന്നെ chemical kinetics ഇന്റെയും കുറേ calculations ഉള്ള questions ആണ് ഇട്ടിരിക്കുന്നത്. ഒരുപക്ഷെ ആ calculations നിങ്ങൾക്ക് എത്രത്തോളം familiar ആണ് എന്ന് എനിക്കറിയില്ല. ഏതായാലും നമുക്ക് ക്വസ്റ്റ്യനിലേക്ക് നേരിട്ട് കിടക്കാം. ഒന്നാമത്തെ ക്വസ്റ്റ്യൻ, which of the following process is not responsible for the presence of electric charge on the salt particles? Sol ennu paranjal endha? A solid in liquid type colloid. That is known as sol. That is, colloids in ഓരോന്നിനും ഓരോ പേരുണ്ട്. That is, നമുക്ക് colloids can be classified based on the physical state of the, so that is the dispersed phase and dispersion medium. Solution അതുപോലെ തന്നെയാണ്. There are 9 type of binary solutions depending upon the physical state of the solute and the solvent. പക്ഷെ ഇവിടെ 9 type ഇല്ല, കാരണം ഗ്യാസ് ഇൻ ഗ്യാസ്, രണ്ട് ഗ്യാസ് നമ്മൾ മിക്സ് ചെയ്താൽ എപ്പോഴും ഹോമോജീനിയസ് മിക്സറാണ്. സൊല്യൂഷൻ ഹോമോജീനിയസ് മിക്സറാണ്, പക്ഷെ കൊളോയിഡ് heterogeneous. But never you will get a colloid by mixing two gases. Dispersed diffusum, dispersion medium gas angle, it is always a homogeneous solution. Baki 8 different type of colloids under, that is gas dispersed in liquid angle, it is foam ennu parayum. Gas dispersed in solid angle, solid form ennu parayum. Liquid dispersed in gas angle, aerosol ennu parayum. Liquid dispersed in liquid angle, emulsion ennu parayum. Then liquid dispersed in solid angle, gel ennu parayum. Adupole solid dispersed in gas, it is solid aerosol. Solid dispersed in liquid, it is salt. Solid dispersed in solid is solid salt. So these are the 8 different type of colloids. But generally, sol it is colloid. And colloids are stable. Why colloids are stable? Because of the charge carried by the colloidal particles. Colloidal particles are having charge. Either they are having positive charge or negative charge. Therefore, when they come together, they will repel each other, and thereby they will not come together and they will not settle down. And that is why colloid is stable. And if somehow the charge is lost, they can come together and they can settle down. And that is called coagulation or flocculation or precipitation. That is, a colloid is get then coagulated or flocculated or precipitated, means it destabilizes the colloid. And how the colloid become, that is how they get charged. That is, they can get charged by the selective adsorption. Selective ADSORPTION, adsorption of a common ion or electron, etc. And that is, colloids are having a large surface area, because the colloidal size is 1 to 1000 nanometer, and therefore they are having very large surface area, and therefore they are having the phenomenon of adsorption. And that is the selective adsorption of a common ion or an electron will give the charge to the colloid. If a colloid is absorbing electron, usually the metallic salts, when they absorb electron, they will be negatively charged. And if you, that is, peptidization is a method of preparation of colloid, that is, it is the opposite of coagulation. A freshly prepared precipitate, when shaken with suitable electrolyte, is converted into its colloid. For example, a ferric hydroxide salt can be prepared by the peptidization of ferric hydroxide with ferric chloride. And the common ion is ferric ion. It is selectively adsorbed on the surface of ferric hydroxide salt, and therefore the ferric hydroxide salt will get positive charge. Similarly, if you add silver nitrate to potassium iodide solution, the reaction takes place and you will get silver iodide. And if excess of potassium iodide is taken and little silver nitrate is added, the silver iodide precipitated will be absorbing the common ion, iodide ion. You will get negatively charged silver iodide colloid. But instead, if excess of silver nitrate is added to little potassium iodide, all the silver iodide get precipitated, colloid get coagulated, and you will get, that is the silver ion is the common ion excess, and that will be selectively absorbed, and you will get a positively charged silver iodide colloid. And that about the charge carried by the colloidal particles are due to the selective adsorption. Here it is asked is, which of the following process is not responsible for the presence of electric charge on the salt particles? A, electron capture by salt particles. Definitely it causes the electric charge. B, adsorption of ionic species from solution. Definitely it also causes the electric charge on the colloidal particles. Formation of Helmholtz electrical double layer. Definitely it also gives charge to the electrical charge to the colloidal particles. Absorption, ABSO, RPTO, absorption of ionic species from the solution. Absorption is not a surface phenomena, it is a bulk property, and therefore it will not take place with colloid, and therefore it is not the reason for the charge carried by the colloidal particles. Therefore the answer is D. That is, which of the following process is not responsible for the presence of electric charge is absorption of the ionic species from the solution. Actually it is adsorption. Our answer is D. Which one of the following is not applicable to the phenomenon of adsorption? Adsorption, it is nothing but a surface phenomena. There is physical adsorption as well as chemical adsorption. If the adsorption, that is adsorbate, is adsorbed on the surface of the adsorbent, and this adsorption, if it is due to weak van der Waals force of attraction, it is called physical adsorption or physisorption. But if chemical bonds are formed between the adsorbate and adsorbent, it is known as the chemical adsorption or chemisorption. And here, whatever be the physical adsorption or chemical adsorption, the residual force of attraction is being satisfied, and thereby it is exothermic and heat will be liberated. As the heat liberated in physisorption is less, it is 20 to 40 kilojoule per mole. But in chemisorption, strong bonds are formed, and therefore the heat liberated will be 80 to 240 kilojoule per mole. And that is the difference between physisorption and chemisorption. Whatever be, it is exothermic, and therefore delta H will be negative. The answer is D. Delta H less than 0. The third question is, which of the following interface cannot be obtained? That is, already I have mentioned that when two gases are mixed, you will get a homogeneous mixture. That means there is no interface between two gases. There may be interface between the gas and liquid. That is known as the surface of the liquid. Or there may be interface between the solid and the gas. That is the surface of the bond. And that means the solid or liquid and solid and gas or liquid and gas, they are having interface. And that is known as the surface. And when two gases are mixed, they will never give that is surface because it is a homogeneous mixture. Therefore, the answer is gas, gas. There also the answer is D. The value of colligative properties of colloidal solution are small order in comparison to those shown by true solutions of some concentration because colloidal particles. What is colligative properties? It is properties of solution. And what is colligative properties? Properties which depends only on the number of solute particles and which does not depends upon the nature of the solute particle. In solution, the solute molecules are dispersed in solvent and the solute molecules are less than 1 nanometer and therefore it is true homogeneous mixture. It is a solution. But if the size of the solute particle is greater than 1 nanometer, it becomes colloid in nature. And that is the difference between these two solution and a colloid. That means it is heterogeneous. It is not homogeneous. But we can see that the colloid can also have colligative properties, and the colligative properties of colloid. What are the colligative properties? One is relative lowering of vapor pressure, and another is elevation of boiling point. The third is depression in freezing point, and the fourth is osmotic pressure. And in the case of colloid, the number of colloidal particles will be less, because in the case, for example, if you get that is a solute and a pure solvent, and you will get a solution. If you take that is 1 mole of a solute, there will be Avogadro number of solute particles, solute molecule in that solution. 6.022 into 10 raised to 23 solute molecules are in that. But in colloid, the particle size is higher. Either it will be multimolecular colloids, or it can be macromolecular colloid with very high, that is molecular mass, or it can be associated colloid. Whatever be, there is large size for colloidal particles. It is greater than 1 nanometer and less than 1000 nanometer. Therefore, the number of colloidal particles will be always less than that of for a pure solution. The colligative property depends only on the number of particles. It does not depend upon the nature of particle, and therefore definitely the colligative property for colloid is very, very small, and only observable colligative properties for osmotic pressure. By using this osmotic pressure, we can determine the molecular mass of these colloidal particles. Now we would answer that is choice, that is because colloidal particles are comparatively less in number. That choice D ആണ്. Are comparatively less in number. Choice D ആണ്. Which of the following statements about enzymes, which one is true? What are enzymes? Enzymes are biological catalysts. Enzymes are biological catalysts. And enzyme lack in specific active sites. It is wrong. Enzymes are having active sites. 2. Enzymes are highly specific both in binding chiral substrates and in catalyzing their reaction. Definitely it is true. Enzymes are highly specific. For example, an enzyme that is in the case of the conversion of that is sucrose into glucose and fructose, it is carried by the enzyme that is sucrose into glucose and fructose. It is carried by the enzyme, which is the enzyme which carry out the sucrose into glucose and fructose. ആരെങ്കിലും പറയോ? ഓർമ്മയില്ല. Sucrose into glucose and fructose. There are various types of enzymes. Diastase will convert starch into glucose. Then the maltose is converted to glucose by the enzyme maltase. And similarly, invertase, the enzyme invertase will convert, that is sucrose into glucose and fructose. That is, sucrose is dextrorotatory, and the mixture of glucose and fructose, it is levorotatory. That is, the optical rotation is inverted when sucrose is converted to glucose and fructose. That is why the enzyme is called invertase and the process is called inversion of cane sugar. Anyway, that is, that invertase cannot convert maltose into glucose. Maltose is cetol S22O11 and sucrose is also cetol S22O11. Both are disaccharide. Maltose is a disaccharide of 2 molecules of glucose and sucrose is a disaccharide of glucose and fructose. And the enzymes are highly specific. The enzyme maltase will convert maltose into glucose, but the enzyme maltase cannot convert starch into, that is sucrose into glucose and fructose. The enzyme invertase will convert sucrose into glucose and fructose, but it cannot convert maltose into glucose. That is, it is highly specific. And you know that is in our body, there are large number of enzymes. In our digestive system also, there is large number of enzymes. And the lack of the enzyme for conversion of, that is we can use the carbohydrate that is edible for us is, that is starch. But we cannot, that is cellulose is another carbohydrate, and we cannot convert cellulose into glucose because the enzyme available in our body is capable of hydrolyzing only starch into glucose. It cannot hydrolyze cellulose into glucose. That is why cellulose is not a nutrient for us, but starch is a nutrient for us. But rodents, or that is the other animals which are having microorganisms which can convert, that is cellulose into glucose, can consume, or that is the cellulose is a nutrient for them. Anyway, that is, enzymes are highly specific. One enzyme, it can carry out only one type of reaction. That is, the reagent is called substrate. It can convert one substrate into a product, and that is enzymes. Our B choice, that is, enzymes are highly specific both in binding chiral substrate and in catalyzing their reactions. It is true. Enzymes catalyze chemical reactions by lowering the activation energy. It is also true. All the catalysts carry out the reaction in an alternate pathway in which the activation energy is decreased. It is true. Pepsin is a proteolytic enzyme. Protein is digested by the enzyme pepsin. Our 2, 3, and 4 are correct, and therefore the answer is C. Which one is true? 2, 3, and 4. Therefore the answer is C. In an adsorption experiment, a graph between log x by m versus log p is found to be linear with a slope of 45 degrees. The intercept on log x by m axis was found to be 0.3010. The amount of the gas adsorbed per gram of charcoal under a pressure of 0.5 atmosphere will be. That is, you know that the Freundlich adsorption isotherm. What is the Freundlich adsorption isotherm states? That is x by m, the specific adsorption. That is, x gram of adsorbate is adsorbed by m gram of the adsorbent, and therefore x by m is the specific adsorption. That is, the amount of adsorbate present per unit gram is directly proportional to the pressure of the gas raised to 1 by n, or x by m is equal to K into P raised to 1 by n. This is the Freundlich adsorption isotherm. If you take the logarithmic form, log x by m is equal to log k plus 1 by n log p. And here it is an equation for a straight line. When you plot the log x by m versus log p, you will get a straight line with slope 1 by n and intercept log k. And that is the Freundlich adsorption isotherm. Here, log x by m versus log p is found to be linear with a slope of 45 degree. That is 1 by n is equal to 45 degree. That is slope is equal to 1 by n, and therefore that is 1 by n is equal to, that is 45 degree, and therefore it is tan 45, that is it is equal to 1. Therefore 1 by n is equal to tan 45 degree, and tan 45 degree is equal to 1. That is 1 by n, it is equal to 1. Therefore it is equal to n is equal to 1. N is equal to 1. Therefore log k is equal to 0.3010. Now what is k? Antilog of 0.3010, and antilog of 0.3010 is equal to 2. Log 2 is equal to 0.3010. Therefore antilog of 0.3010 is equal to 2. Therefore n is equal to 1 as well as k is equal to 2. And at p is equal to 0.5 atmosphere, x by m is equal to k into p raised to 1 by n, and therefore that is x by m is equal to 2 into k is equal to 2, and p is 0.5 raised to 1. Therefore x by m is equal to 2 into, that is 0.5 raised to 1, that is it is equal to 1. That is x by m is equal to 1. And the answer is, the choice and one another. The choice is A. On adding silver nitrate solution to potassium iodide solution, a negatively charged colloid salt will be formed in which of the following conditions? I already mentioned that you can prepare a silver iodide colloid by adding silver nitrate to excess of potassium iodide, because iodide ion is selectively adsorbed. And if you are using excess of silver nitrate added to little potassium iodide, then excess of silver ions are there, and you will get a positively charged colloid. And you can apply that phenomena, and thereby, that is on adding silver nitrate solution to potassium iodide solution, a negatively charged colloid, that means it should be potassium iodide should be excess. And in choice A, 100 ml of 0.1 molar silver nitrate and 100 ml of 0.1 molar potassium iodide, both are equal. B choice, 100 ml of 0.1 molar silver nitrate and 50 ml of 0.2 molar, both contain same moles of potassium iodide and silver nitrate, because 100 into 0.1 10, 50 into 0.2 10. 100 ml of 0.2 molar silver nitrate and 100 ml of 0.1 molar potassium iodide. Here it is 20 AgNO3 and 10, that is potassium iodide. You will get a positively charged colloid. And in D choice, 100 ml of 0.1 molar silver nitrate 10 and 100 ml of 0.15 molar potassium iodide, that is 15. There is excess of potassium iodide. You will get a negatively charged colloid, because potassium iodide is excess, iodide ion are common ion, and that will be selectively adsorbed. In Langmuir's model of adsorption of a gas on a solid surface, Freundlich adsorption isotherm, it corresponds to physical adsorption, and Langmuir model of adsorption of a gas on a surface, solid surface, it is corresponding to chemical adsorption. Choice A, the rate of dissociation of adsorbed molecules from the surface does not depend on the surface covered. B choice, the adsorption of a single site on the surface may involve multiple molecules at the same time. Langmuir adsorption is corresponding to chemical adsorption, and the chemical adsorption is monolayer, whereas physical adsorption is multi-layer. Therefore, B is not correct. The mass of gas striking a given area of surface is proportional to the pressure of the gas. It is true. That is, answer is C. 9th question. It converts alcohol directly into gasoline by dehydration. It is the shape selective catalyst ZSM5. It is catalyzing the conversion of alcohol into gasoline. Alcohol ne petrol akan ubhayikkunnathu the shape selective catalyst zeolite, that is ZSM5. Our choice is C. Consider the following reactions. 2SO2 plus O2 give 2SO3. The contact process for the manufacture of sulfuric acid, and you have to use vanadium pentoxide as the catalyst. It is a reaction which is using a catalyst. And N2 plus 3S2 give 2NS3. Haber process for the manufacture of ammonia. It is also using a catalyst ion and is used as a catalyst. And C choice, N2 plus O2 give 2NO. It doesn't require any catalyst. S2 plus I2 give 2HI. It also doesn't require any catalyst. The reaction which require a catalyst are A and B. Therefore, the choice is C. 11th question is, if X by M is the mass of adsorbate, adsorbed per unit mass of adsorbent, P is the pressure of the adsorbate gas, and A and B are constants, which of the following represents Langmuir adsorption isotherm? I already mentioned that the Langmuir adsorption isotherm, which is for the chemical adsorption, and the Freundlich adsorption isotherm is for the physical adsorption, and the Freundlich adsorption isotherm is X by M is equal to K into P raised to 1 by N, but the Langmuir adsorption isotherm, it is X by M is equal to A into P. X by M is equal to A into P by 1 plus BP, where A and B are constant, and X is the amount of adsorbate and M gram of the adsorbent, and P is the pressure of the gas. This is the Langmuir adsorption that is the isotherm. And if you consider this Langmuir, but the choices are given is, it is not the X by M is equal to A into P by 1 plus BP, and various other choices are given, and therefore you have to use log X by M is equal to log A by B plus 1 by A log P. You will not get the value when you take the logarithmic form of that. X by M is equal to B by A plus 1 by AP. You will not get that value. And X by M is equal to 1 plus BP by AP. You will not get the value. But if you consider 1 by X by M, 1 by X by M is equal to 1 by, that is AP by 1 plus BP, and that is, it is equal to 1 plus BP by AP. And when you do it, you will get B by A plus 1 by AP. Sorry, AB alla AP. That is, X by M is 1 by X by M is equal to B by A plus 1 by AP, and that is, it is equal to 1 by AP plus plus B by A, plus B by A, and that is X by 1 by X by M is equal to 1 by AP plus B by A, and therefore the choice is D. B by A plus 1 by AP. That is, the choice is D. And that about the surface chemistry and colloids. Then there is chemical kinetics. Chemical kinetics deals with the rate of reaction as well as the factors influencing the rate of reaction. And the rate of a reaction is the change in the concentration of any one of the reactants or product per unit time. And the factors influencing the rate of reaction is nature of the reactants, concentration, temperature, then the pressure, as well as the catalyst. These are the various factors influencing the nature of the what is the rate of reaction. Anyway, that is the unit of rate of reaction is, there are two types of rate of reaction, that is the average rate as well as the instantaneous rate. And for average rate, it is a change in concentration per unit time, that is mole per liter per unit time. It can be mole per liter per second, or mole per liter per minute, or mole per liter per hour, or mole per liter per year, etc. And that is in the case of average rate. But instantaneous rate means the time is in second, and therefore the unit is mole per liter per second, and that about the unit of rate of reaction. But the rate of reaction, that is we can experimentally, that is we can carry out the rate of reaction, and we can see that certain reactions, they are directly proportional to the concentration, that is such as first order reaction. And if the rate is independent of the concentration of the reactants, it is a zero order reaction. And order of a reaction is the power to which the rate of the concentration term is raised in the rate law. So what is the rate law? Rate law is the equation which relate the rate of reaction and the concentration of the reactants. For example, if the rate is equal to K, that means there is no concentration term. It is a zero order reaction because the concentration rise to zero is 1. But if the rate is equal to K into active mass of the reactant, it is a first order reaction. If the rate is equal to K into active mass of the reactants rise to 2, it is a second order reaction. That about the order of the reaction. And the unit of the rate constant, K, how will the K is defined? It is the rate of reaction when the molar concentration of all the reactants are unity. Whatever be the order, when the concentration of all the reactants are taken as 1 mole per liter, then what is the rate obtained? And that is known as the rate constant. And therefore the rate constant, it is also known as specific reaction rate. And the unit of rate constant depends upon the that is the order of that reaction. In general, the unit of an nth order reaction is mole per liter raised to 1 minus n per second, where n is the order of that reaction. That is for zero order reaction, 1 minus n is equal to 1. Therefore, it is mole per liter per second. The unit of rate and rate constant are same. But for a first order reaction, 1 minus n means 1 minus 1, 0. That it is per second. For a second order reaction, it is 2 minus 1 minus 2, it is minus 1. That is the liter per mole per second. Likewise, and that is the unit of the rate constant depends upon the order of that reaction. Anyway, that is here the first question is, in a first order reaction, R gives Q. If K is the rate constant and initial concentration of the reactant is 0.5 mole, then the half-life is, the half-life of a reaction, it is nothing but the time required for half of the reactant to react. What is half-life? It is the time required for half of the reactant to react. And if you consider in the case of a first order reaction, the half-life is independent of the initial concentration, and it is equal to 0.693 by K. The T-half of a first order reaction is 0.693 K by K, where K is the rate constant. And how will you get the 0.693? It is 2.303 into log 2. That is, log 2 is 0.3010. Therefore, 2.13 into log 2 by K. and that is 2.3 log 2 is equal to natural logarithm 2 log n 2 by k. And therefore, half-life of a first order reaction, it is log n 2 by k, and that is answer is C. Answer is C. Match the plots given in list 1 with the slopes given in list 2 and select the correct answer using the codes given below. List 1, P, C versus T, concentration versus time for zero order reaction. We know that for a zero order reaction, the concentration versus time is a straight line, because the rate is always independent of the initial concentration. Whatever be the concentration, the rate is same. And therefore, when you plot the concentration versus time, you will get a straight line. And the slope of that straight line will be minus k. The slope of the straight line will be minus k. Therefore, P is corresponding to 3. And P corresponding to 3. Then log concentration versus time for first order reaction. For first order reaction, the concentration versus time is not a straight line, because during the course of time, the concentration of the reactants decreases and the rate will also decrease, because the rate is directly proportional to the concentration. And therefore, the log concentration versus time will be a straight line for first order reaction. And the slope is minus k by 2.303 for a first order reaction. Our Q is equal to 4. P is equal to 3 and Q is equal to 4. Minus dz by dt, rate versus concentration. Rate versus concentration is a straight line for zero order reaction. That is, it is parallel to the concentration axis, because the rate is independent of the concentration. Therefore, we will get a line parallel to the concentration. Rate is a constant. That means its slope is equal to 0. It is equal to 0. That is, R is equal to 2. And for log concentration versus, that is log rate by log concentration for first order reaction, it is unity, because that is log rate by log concentration. The slope will be unity, and therefore answer is B. P3, Q4, R2, and S is equal to 1. In most cases, for a rise of 10 Kelvin temperature, the rate constant is doubled. This is due to the reason that we have mentioned that the factors influencing the rate of reaction are concentration, then temperature. What is the effect of temperature? In the case of concentration, either it will be that is directly proportional to the concentration, or it is independent of the concentration, or it is directly proportional to the square of the concentration, or it is directly proportional to the square root of concentration, likewise. And that about in the case of the effect of concentration on the rate of reaction. But the effect of temperature on the rate of reaction is enormous. For slight increase in temperature, the rate of reaction enormously increases. And the reason is, for a reaction to take place, the reacting molecule has to collide each other. And all the molecular collision will not result in product, because for converting the reactants into product, the colliding molecule must possess a minimum energy, which is known as threshold energy or activation energy. That is, only those molecular collisions which are effective collisions. Effective collision means which will result in product. And for an effective collision, the colliding molecule must possess minimum energy called threshold energy or activation energy. And when the temperature increases by 10 degrees, the fraction of molecule possessing this activation energy and above is also doubled or even increase to threefold. And Arrhenius found that is the effect of temperature on the rate of reaction can be used. It is directly proportional to the fraction of molecule possessing the activation energy and above, and it is exponential of minus EA by RT, where A is the activation energy and R is the universal gas constant and T is the temperature in Kelvin scale. And this is the fraction of molecule possessing activation energy and above. And therefore, the rate constant or rate is directly proportional to E, that is exponential of minus EA by RT, or it is equal to an Arrhenius constant, that is A exponential of minus EA by RT. And this is the Arrhenius equation for the effect of temperature on the rate of reaction. And here we can see that for every 10-degree rise in temperature, the fraction doubles, means the rate also doubles. Or if the fraction increases by threefold, then the rate also increases by threefold. If 0 degree 10 degree like rise cheyidal, adinte concentration, that is rate double cheyunnu ennu paranjal, that is 273 in 283 like varumbode Kelvin le, the rate is double. And such relationship is known as the temperature coefficient. The rate constant at T plus 10 by the rate constant at T. It is known as the temperature coefficient. Its value is 2 to 3. That is, for every 10-degree rise in temperature, the rate is doubled or it increases by threefold. And then the reason is the fraction of molecule possessing this activation energy and above is high increasing. Appo choice avade endha B aanu. Fraction of molecule possessing threshold energy increases by a factor of 2 to 3. Answer is B. 15th question. The rate of change of concentration of A for reaction A gives B is given by minus dA by dt. It is a rate is equal to K into that constant into active mass of A raised to 1 by 3. The order of that reaction is 1 by 3. Order can have any value: 0, negative, fractional, or positive integer. It should be experimentally determined. But in the case of molecularity, another term, it is the number of molecules taking part in a reaction. It will never be 0 or fractional. It is always a positive integer. And in the case of elementary reaction, single step reaction, the order and molecularity will be same. But for complex reaction means a reaction which will take place in more than one step. Each step is having its own molecularity, and the lowest, the rate, that is the rate determining step, or that is the step which takes place at slowest rate. That is slowest rate. That is known as the rate determining step, and the molecularity of the slowest step will be the order of that reaction. That is, elementary reaction means single step reaction. In single step reaction, the order and molecularity are same. But for multi-step reaction, it is complex reaction. Each step is having its own rate, and the molecularity of the slowest step, which is known as the rate determining step, because the overall rate cannot exceed that rate, and that is known as rate determining step. And the molecularity of that rate determining step will be the order of that reaction. Anyway, the rate law states that minus dA by dt is equal to K into active mass of A raised to 1 by 3. That is, it is 1 by 3 order. The half-life period of the reaction will be. We have seen that in the case of first order reaction, the half-life is independent of the initial concentration. And for a zero order reaction, the half-life is inversely, it is directly proportional initial concentration. For a second order reaction, the half-life is inversely proportional to the initial concentration. Or in general, T half of an nth order reaction is directly proportional to the initial concentration. If A is the initial concentration, A raised to, that is n minus 1, where n is the order of that reaction. That is, for a first order reaction, that is, it is n is equal to 1, 1 minus 1 is equal to 0. That means half-life is independent of the initial concentration. For a zero order reaction, n is equal to 0, 0 minus 1 means A raised to minus 1, 1 by A raised to minus 1 is equal to, that is A. That is, half-life is directly proportional to the initial concentration. For a second order reaction, that is, half-life is inversely proportional to A raised to 2 minus 1. It is inversely proportional to the initial concentration. And therefore, here it is, the order is 1 by 3. Therefore, it is directly proportional 1 by 3, A raised to 1 by 3 minus 1. 1 by 3 minus 1 is equal to minus 3. 1 by 3 minus 1 by 3 minus 1. That is, it is equal to 1 by 3 minus 3 by 3. It is minus 2 by 3. That is, half-life is proportional to the concentration raised to 2 by 3. Half-life is directly proportional to the concentration raised to 2 by 3. And here, the choices is different. It is not, it is equal to, it is not, that is directly proportional. Namakariam first order reaction the case half-life is independent of the initial concentration work out that is the logarithmic form that is for first order reaction minus dA by dt, it is equal to K into active mass of A, and therefore that is minus dA by A is equal to, this is for first order, minus dA by A is equal to K into dt, integrating this, minus integral dA by active mass of A is equal to K integral dt, and therefore it is equal to minus log n A is equal to K into T plus C, and when T is equal to 0, A is equal to A0, and substituting the value of, that is this, when T is equal to 0, K into T is equal to 0, therefore minus log n A is equal to C, that is minus log n A is equal to K into T minus log n A0, or log n A0 minus log n A is equal to K into T, or K into T, or K is equal to 1 by T into log n, that is A0 by A, where A0 is the initial concentration and A is the concentration at the time interval T. This is the integrated rate equation for first order kinetics, and it is not natural logarithm, log n. And therefore, converting this into log to the base 10, you have to multiply by 2.03, 2.03 by T into log to the base 10, A0 by A. This is the integrated rate equation for a first order kinetics. And we can see that, that is when half-life is considered T of A is equal to A0 by 2. And therefore, A is equal to A0 by 2. Therefore, it is equal to log 2. And therefore, T of is equal to 2.303 by K into log 2. Log 2 is equal to 0.3010. Therefore, 2.303 into 0.3010 by K. That is, it is equal to 0.693 by K. Likewise, this is for a first order reaction. Likewise, for this 1 by 3 order, we can carry out the equation, and that is, here the order is 1 by 3, and therefore we can say that minus dA by dt is equal to K into active mass of A raised to 1 by 3, or integral dA by active mass of A raised to 1 by 3 is equal to integral K dt. That is the integration can be carried out. Minus dA by dt is equal to K into active mass of A raised to 1 by 3. And therefore, that is minus dA by active mass of A raised to 1 by 3 is equal to K into dt minus dA by A raised to 1 by 3 is equal to K into dt. Integrating this equation, that is, you will get, that is 3 by minus 3 by 2 A raised to 2 by 3 is equal to KT plus C. And when T is equal to 0, then A is equal to A0. Therefore, minus 3 by 2 A0 raised to 2 by 3 is equal to C. Substituting the value of C there, you will get minus 3 by 2 A raised to 2 by 3 is equal to K into T minus 3 by 2 A0 raised to 2 by 3. And therefore, K into T is equal to, that is 3 by 2 A0 raised to 2 by 3 minus 3 by 2 A raised to 2 by 3. And that is T is equal to T of A is equal to A0 by 2. T is equal to T of formula, that is A is equal to A0 by 2. And therefore, that is K into T of is equal to 3 by 2 A0 raised to 2 by 3 minus 3 by 2 A0 by 2 raised to 2 by 3. You will get T of is equal to, that is 3 into A0 raised to 2 by 3 into 2 raised to 2 by 3 minus. That means the choice is, that is T of is equal to 3 into A0 raised to 2 by 3. Choice is C on 3 into A0 raised to 2 by 3 into 2 raised to 2 by 3 minus 1 by 2 raised to 2 by 3 into K. Choice is C on. 16th question is, for the reaction 4A gives 3B plus C. That is, we know that the rate of a reaction is the change in concentration per unit time. And when you take more than one reactant, how can you equate the rate with respect to each reactant and product? That is, MA plus NB gives PC plus QD. How can you equate this? Minus 1 by M dA by dt is equal to minus 1 by N dB by dt. It is equal to 1 by P dC by dt is equal to 1 by Q dd by dt. That is, you have to divide each concentration term by the coefficient appearing in the balanced equation. For example, in the Haber process, N2 gas plus 3S2 gas give 2NS3 gas. Here, how can you get minus dN2 by dt? It is equal to 1 by 3 ds2 minus 1 by 3 ds2 by dt. It is equal to half dns3 by dt. This is simple, because if you take 10 mole of nitrogen, it requires 30 mole of hydrogen to give 20 mole of ammonia. Because 1 mole of nitrogen requires 3 mole of hydrogen to give 2 mole of ammonia. Therefore, 10 mole of nitrogen, if it reacts with the 30 mole of hydrogen to give 40 mole of ammonia, isn't it? Therefore, rate with respect to nitrogen, if it is 10 mole per liter per second, what will be the rate with respect to hydrogen? 30 mole per liter per second. Because within 1 second, 30 mole of hydrogen will react. Then how can you equate it? 10 is equal to 1 by 3 into 30. And there 40 moles of ammonia will be formed. And therefore it is equal to, that is half into 40. Sorry, that is 20 mole of 10 mole will give 20 mole. 10 mole will react with 30 mole of hydrogen to give 20 mole of ammonia. But 20 into half, that is 10 mole per liter per second. That is, in order to equate the rate with respect to each reactant and product, you have to divide each concentration term by the coefficient appearing in the balanced equation. That's the meaning. That is, 1 mole nitrogen, 3 mole hydrogen, 2 mole ammonia form ചെയ്യുന്നു പറഞ്ഞാൽ rate with respect to nitrogen 1 mole per liter per second ആണെങ്കിൽ അതേ ഒരു സെക്കൻഡിൽ 3 mole hydrogen decompose ചെയ്യും. കാര്യം 1 mole nitrogen 3 mole hydrogen വേണം. അപ്പോൾ തമ്മിൽ റേറ്റിൽ വ്യത്യാസം എങ്ങനെ? ഒന്ന് 1 mole per liter per second, മറ്റേ 3 mole per liter per second. അപ്പോൾ അതിനെ ഇക്വേറ്റ് ചെയ്യുന്നത് എങ്ങനെയാ? 1 is equal to 1 by 3 into 3. And that is the way. And here, what is the equation? Equation is 4a gives 3b plus c. 4a gives 3b plus c. This is the equation. And how can you get minus 1 by 4 dA by dt is equal to minus 1 by, so it is not minus. With respect to reactant, it is negative because the concentration of the reactants decreases. The final concentration will be less than initial concentration, but rate is never negative. And to make the rate positive, you have to put the negative sign. It is equal to 1 by 3 into dB by dt. It is equal to dC by dt. How can you equate the rate with respect to A, B, and C? And here it is given that minus dA by dt, minus dA by dt, it is equal to K1 into active mass of A raised to 4. That is the rate with respect to A is equal to K1 into active mass of A raised to 4. What is the 1 by 4th of the rate? It is equal to 1 by 4 K1 or K1 by 4. K1 by 4 into A raised to 4. That is 1/4 of the rate with respect to A. Similarly, the equation with respect to dB by dt is equal to K2 into A raised to 4. And therefore it is equal to K2 by 3. K2 by 3 into A raised to 4. And here with respect to C, it is equal to K3 into A raised to 4. It is nothing but K3 into A raised to 4. And now we can see that K1 by 4 is equal to K2 by 3, which is equal to K3. K1 by 4 is equal to K2 by 3, which is equal to K3. And therefore, how can you get it? A common factor 12 which multiply in the term. That is 3K1 is equal to 4K2 is equal to 12K3. Isn't it? And therefore, the answer is 3K1 is equal to 4K2 is equal to 12K3. It is answer is B. The choice is B. 17th question is the rate law for the reaction 2S2 plus 2NO gives N2 plus 2S2O. That is, the chemical kinetics deals with the rate of reaction, the factors influencing the rate of reaction, as well as it gives information about the mechanism of a reaction. And what do you mean by the mechanism of a reaction? What are the steps involved in the reaction? That is known as the mechanism of a reaction. And in the case of, if you consider the reaction that is carbon dioxide, carbon monoxide plus, that is nitrogen dioxide give CO2 plus NO. Carbon monoxide gas plus NO2 gas give carbon dioxide gas plus NO gas. And this reaction, when you experiment is carried out and the rate law is found, the rate is equal to K into active mass of NO2 raised to 2. That means it is zero order with respect to carbon monoxide and the second order with respect to nitrogen dioxide. Actually, the molecularity of carbon monoxide is 1 and nitrogen dioxide is also 1. Therefore, if it was a elementary reaction, the rate law should be rate is equal to K into active mass of CO into active mass of NO2. Because for elementary reaction, the order and molecularity are same. But here the order is different from molecularity. And therefore, it is not an elementary reaction. It is a complex reaction. So we have to deduce the mechanism. That is the rate determining step contain 2 molecules of NO2. Therefore, the rate determining step will be NO2 plus NO2 gives NO3 plus NO. This is a slow step. Therefore, it is a rate determining step. As soon as NO3 is formed, it will combine with carbon monoxide to give NO2 plus CO2. And when you add these two equations, this is a fast reaction. And when you add this equation, that is, you will get NO2 plus CO give NO plus CO2, the required equation. That means the probable mechanism, it is a two-step mechanism. And the slower step, there are 2 molecules of NO2 taking part. That means it is a second order with respect to NO2. And this is the way in which we can deduce the mechanism of a reaction. Here, which of the following mechanism is consistent with rate law? Here it is first order with respect to hydrogen, but the molecularity is 2. And it is second order with respect to NO, the molecularity is also 2. Therefore, it is not an elementary reaction, it is a complex reaction or a multi-step reaction. In the rate determining step, there will be 1 molecule of hydrogen and 2 molecules of NO2 will take place. Our choice A, 1 molecule hydrogen, 2 molecule NO പങ്കെടുക്കുന്നുണ്ട്. That may be the mechanism. And D choice 1 molecule of hydrogen, 2 molecules of NO പങ്കെടുക്കുന്നുണ്ട്. പക്ഷേ D choice product കിട്ടുന്നത് N2 plus H2O എന്നുള്ളതാ. അതിൽ നമുക്ക് അടുത്ത സ്റ്റെപ്പിലേക്ക് പോകാൻ കഴിയില്ല. അതേസമയം ആ ഫസ്റ്റ് എ ചോയ്സിൽ that is അത് N2O plus H2O ആണ്. ആ N2O plus H2O N2O ഉണ്ടാകുമ്പോൾ തന്നെ വീണ്ടും അതൊരു മോളിക്യൂൾ ഹൈഡ്രജനുമായിട്ട് റിയാക്ട് ചെയ്ത് N2 plus H2O ഉണ്ടായി കഴിഞ്ഞാൽ 2 സ്റ്റെപ്പായി. അത് രണ്ടും കൂടെ ആഡ് ചെയ്യുമ്പോൾ you will get the equation 2H2 plus 2NO give N2 plus 2H2O. That is the probable mechanism is two-step mechanism and the slowest step is A. In the concentration of B at the point of intersection of the 2 curves as shown in the figure, A gives NB is. Avade, that is the rate of forward reaction and rate of backward reaction, that is equal I, and thereby that intersection means avade എത്രയാണോ concentration of the reactants decay ചെയ്ത് അത്ര തന്നെ product concentration increase ചെയ്തു. And that is why there is intersection of that reaction. And here we can see that that is the choice is C. എന്തുകൊണ്ടാ? Active mass of A left is equal to active mass of B formed, and therefore it is equal to, that is active mass N into active mass of A decayed, and therefore C0 raised to C0 into E raised to minus KT is equal to N into C0 raised to 1 minus E raised to minus KT. Our formula you will get answer is C. Then 19th question is the rate expression for the reaction A gas plus B gas gives C gas. Is rate is equal to active mass of K raised to 2 into active mass of B raised to half. What changes in the initial concentration of A and B will cause the rate of reaction to increase by a factor of 8? It is a second order reaction with respect to A. Molecularity 1 ആണ്, പക്ഷെ order with respect to A is 2. B യുടെ molecularity 1 ആണ്, പക്ഷെ order it is half. അപ്പോൾ A യുടെ concentration double ചെയ്താൽ rate 4 times ആവും. ഇവിടെ rate 8 times കിട്ടണം എന്നാ പറയണത്. അപ്പൊ A യുടെ concentration double ചെയ്താൽ rate 4 times ആവും. പിന്നെ B യുടെ concentration എത്ര മാറിയാലാണ് rate വീണ്ടും 2 times ആകുക? അപ്പൊ therefore 4 into 2 8 times ആവും. എന്ത് വേണം? B 4 times increase ചെയ്യണം. 4 raised to half is equal to 2. Square root of 4 is equal to 2. Therefore, that is the concentration of A should be 4 times and A should be 2 times and the concentration of B should increase by 4-fold. And therefore the answer is B. ഈ ക്വസ്റ്റ്യൻസ് ഒക്കെ ഉണ്ടായിരുന്നു അതിനകത്ത്? ഉണ്ടല്ലോ അല്ലെ? 19. അടുത്ത 20ാമത്തെ ക്വസ്റ്റ്യൻ സൊല്യൂഷന്റെ ആണെന്ന് തോന്നുന്നു അല്ലെ? Which of the following is a colligative property? Osmotic pressure of a solution. So it's a C ആണ്. ഇനി observed colligative property and theoretical colligative property assuming normal behavior of solute, then Van der factor I is equal to observed colligative property by theoretical colligative property. Appo answer D ആണ്. Pi observed by pi calculated. What will be the ratio of any of the colligative properties of 1 molar aqueous solution of sodium chloride, Na2SO4, KO4 FeCN5? That is, if there is 100% dissociation, the number of ion will give Van der factor. Sodium sulfate 2 sodium ആണ്, 1 sulfate ആണ്. അപ്പോൾ Van der factor is equal to 3 ആണ്. Sodium chloride 1 sodium ആണ്, 1 chloride ആണ്, Van der factor 2 ആണ്. And potassium ferrocyanide 4 potassium അയണും 1 ferrocyanide അയണും Van der factor 5 ആണ്. അപ്പോൾ therefore that is the ratio will be 2:3:5. Choice C ആണ്. Which of the following has highest osmotic pressure? ഇവിടെ എല്ലാം m/10 മോളാർ, കോൺസെൻട്രേഷൻ സെയിം ആ. അപ്പൊ pi is equal to ICRT ആ. ഇപ്പൊ Van der factor മാറുന്നുണ്ട് അല്ലേ? Van der factor for HCl 2 ആണ്, യൂറിയ 1 ആണ്, and BaCl2 3 ആണ്, and glucose 1 ആണ്. അപ്പൊ ഏതിനാ മാക്സിമം? BaCl2, Van der factor 3. ചോയ്സ് C ആണ്. നോക്കൂ, അവിടെ B and D are isotonic because they are equimolar as well as their osmotic pressure will be same. A solution contains 1 mole of solute of molecular mass Mb. Which of the following can be used to calculate the molecular mass of the solute in terms of osmotic pressure? And the osmotic pressure equation and the pi is equal to n/v into RT, or it is equal to Wb by Mb into RT by V. And what is molar mass? Mb is equal to WRT by pi V. Molar mass Mb is equal to WBRT by pi V. Our choice is avade Mb is equal to WBRT by pi V. Choice B. At the 0.6 gram of a solute is dissolved in 0.1 liter of a solvent which develops an osmotic pressure of 1.23 atmosphere at 27 degrees Celsius. The molecular mass of this question തന്നെയാണ്. WB എത്രയാ? 0.6. R ന്റെ value 0.0821. 27 degree means 300 Kelvin divided by osmotic pressure 1.23 and volume in liter is equal to 1.1 liter. This ചെയ്യുമ്പോൾ that is 0.1 and 0.6 കൂടെ 6 times ആയി, and that is 0.6 അല്ലേ? And here it is 0.08 through 21 into 300 കിട്ടുന്നത് 24.63 ആ. അപ്പോൾ 6 into 24.63 by 1.23. 1.23 that is 24.63 കൂടെ 20. 6 into 20, it is equal to 120 gram. the molecular mass is equal to 120. And that about the solution. And this is the way in which we can calculate the molar mass of a solute. All the four colligative properties are used to determine the molar mass of a solute. The relative lowering of vapor pressure, or elevation of boiling point, or depression freezing point, or osmotic pressure. And that about the solution. Okay, thank you very much.